Hello students, welcome to Vijetha IAS Academy, New Delhi. So myself is Lenin and I have been associated with UPSC for the past 7 years and I am the faculty of geography at Vijetha IAS Academy. In this video, we will see one particular topic from geography, especially this El-NINO and La Nina. This has been seen regularly in news, especially this topic is associated with India also. Okay, this is a phenomena that is occurring at the global level, but it will have an impact on India also. Okay, so we will see how this El-NINO will have an impact on India and how this La Nina is having an impact on India. And apart from this El-NINO and La Nina, there are other associated topics like Madden-Julian oscillation and also one more topic called as Indian Ocean Dipole. Okay, so we will see all these 4 topics and what are the impacts of all these 4 topics on India. Okay, so first we will start with certain basics regarding these topics and we will understand what are the different basics, then we will see how these things are there. Okay, so first we will see one subtopic called as upwelling and downwelling. Okay, so if you remember, in a crude way, upwelling is nothing but something is coming upwards and downwelling is something that is going downwards, but in geography perspective we will see what is upwelling and downwelling in detail. Okay, so if you see, okay, so I'll take a coastline. Okay, so I'll draw a coastline so that we'll see. Okay, so this is the coastline and it is the associated, this one is ocean. Okay, so let us now take some winds that are blowing away from the coast, means that are going away from the coast towards the ocean. Okay, so when some wind is going away from the coast and these winds, when they are blowing, they will try to drag the water that is associated with the bottom layer of the air. Okay, so if some layer of air that is blowing here, this layer of air will try to drag the water that has been attached to this air surface. Okay, so because of this one, the air will start moving away from this coast. Okay, so in that process some water will be reduced at this coast and some water will start accumulating here away from the coast. Here the water level has been reduced as lot of water has been dragged away from this coast, and whatever the water that have been dragged away from this coast will start accumulating somewhere away from the coast. As lot of water have been dragged away from this coast, the level has been reduced, but because of the atmospheric pressure, whatever the water level that is there, that will be balanced so that water level will try to come on the equal base. Okay, so because of that one, as there is a bit of empty space here, as the water have been dragged, some water from the bottom will try to come towards the surface. Okay, remember, as there is some empty space here, some water will try to come from the bottom of the surface so that whatever the water that is coming from the bottom will start filling this empty space so that once again the water level will become equal. Okay, so this, as some water is coming from the bottom and it is filling here, so this is called as upwelling. This is called as upwelling. So upwelling is nothing but some water that is present at the bottom will start coming towards the surface to fill the space that is left over the surface because of the dragging of air from the coast into the ocean. Okay, so this is upwelling. And if you see from this picture, see some water that have been, see this is the wind direction, wind have been blowing on the surface from the coast towards the ocean. So this wind will drag certain water away from the coast so that a little bit empty space will be created here. So that empty space will be filled by the water that is coming from the bottom. Okay, as water is coming from the bottom, it is called as upwelling. Is it clear? So next we will see what is downwelling. Okay, so in this case we will once again take the same coast. Okay, so in this case also we will take once again the same coast and also we will take the water that is present. Okay, but here we will see the water how See, in this case we will take the winds that are blowing towards the land, okay, from the ocean. We will take the winds that are blowing towards the land or towards the coast. As winds are blowing towards the coast, these winds will try to drag the water that is present on the ocean towards the coast. So because of that one, if you see, because of that one, water will start accumulating, because this entire water that are present on the surface will be dragged towards the coast and water will start accumulating here, and a little bit water level will be reduced away from the coast. As more water have been accumulated at the coast, the density of water will start increasing. Once the density of water have been increased, its weight will increase. So because of that one, the water will try to go down. Okay. So here, because of increasing in the weight, this water will try to go down like this. As water is going down, so this water level at the coast will start receding, so that once again a balanced height of the water will be achieved. Okay. And in this process, as water is going down, okay, this is called as down welling. Okay. So this is upwelling, where water from the bottom of the ocean will try to come towards the surface, and in downwelling, water from the surface will try to go below the surface of the ocean. Okay. Have you understood? So from this picture, if you see, the water is dragging, means this air that is blowing on the ocean towards the coast will try to drag the water towards the coast. So because of that one, lot of water will be accumulated here, and as water is accumulated on the coast, the density of water will increase. This high density water will start sinking down, and this water will be dragged towards the bottom. Okay, can you see from this picture, the water will be dragged towards the bottom. This is nothing but called as downwelling. Hope you understood this topic. Okay, so we will see the next topic associated with this El-NINO and La Nina. Then we will go into the major topic of our El-NINO and La Nina. Is it clear? So now we will see one more topic. See, let us understand. See, when any surface have been heated, okay, let us assume this is the surface. Let us assume this is the surface of the earth. Once this surface have been heated, so this will become very warm, okay, very hot, right? So the air attached to this surface, the air attached, especially see, if you see, this is the air layer that is present above the earth surface, which is attached to the earth surface, and there is one more air layer. This is the second air layer, this is the third air layer, this is the fourth air layer. So like this, different air layers will be there above the earth surface. But if you see the air layer that is attached to the earth surface, okay, we will see about this air layer which is attached to the earth surface. As we know, once this surface has become very hot, it will transfer its heatness or hotness to this immediately layer that is attached to the surface. Okay, the layer will get warm because it is attached to the earth surface. Once the layer of air which is attached to the earth surface becomes warm, means it becomes very hot, it will try to expand. Okay, remember, once the air layer which becomes hot, it will try to expand, and in the process of expansion it will become lighter, because the particles or the density of the air will start reducing, because previously, let us assume 100 particles are there which are accumulated in this small area. Okay, so its density will be high, but once the air has been expanded, these particles will start accumulating in this entire area. Once the particles have been dispersed or distributed in larger area, its density will become less. Once its density is becoming less, means it will become lighter in weight. Once it becomes lighter in weight, then it is easy for that air to rise upwards. So if you see clearly, this is the earth surface which is very warm, and this is the air layer which is attached to the earth surface, will also become warm, and this air layer will start expanding. In the process of expanding, it will become lighter in weight. Once it becomes lighter in weight, it will try to move upwards. Okay, once it becomes lighter in weight, it will try to move upwards. In the process of moving upwards, whatever the warmer air packet is there, whatever the warm air that is there, in the process of moving upwards, it will become little bit cooler and cooler with height. Okay, so this warm air which is rising in the process will become cooler. Once it becomes cooler and cooler, it will try to condense and it will lead to the formation of clouds if any moisture is present within this warm air packet. Remember, if any moisture is present in this warm air packet, in the process of rising, okay, in the process of uplifting, this warm air will try to become cool, and in the process of becoming cool, the air will condense and it will lead to the formation of clouds. Okay, it will lead to the formation of clouds, and if the water content have been increased further, then these clouds will start giving us rainfall. This will give rainfall. So remember, wherever the warm air is there, it will try to expand. In the process of expansion, it will become lighter in weight, and once it becomes lighter in weight, it will try to uplift. In the process of uplifting, it will become cool and it will condense and it will form clouds and it will give rainfall. Remember, those airs which are rising, they will only give rainfall. And there is another phenomena where, see, if you see from this picture, ground surface has been heated, and because of heating, the air will start rising. So because of heating of the ground, the air attached to that one will also become warm, will expand, and it will try to rise. In the process of rising, it will lead to the formation of clouds, and these clouds will give us rainfall. So rising airs, remember, rising air has a chance of forming clouds. Okay, I am not saying 100% they will give rainfall, but there might be chances of forming into clouds and giving rainfall. Okay, so similarly, when any air that is coming down, okay, when any air, see, okay, one more thing which we have to remember here is temperature here near the surface is hot, right? So once the temperature is hot, it is expanding, right? Once it is expanding, it is becoming lesser in weight. So because of lesser in weight, the air will start rising. As the air has been expanding and becoming lesser in weight, the pressure applied by that air on the surface will be less. Okay, so once the air is lesser in weight, the pressure applied by that air packet on the surface will be less. So due to that one, here we will have less pressure. Okay, there will be low pressure. So remember, wherever there is high temperature, because of that one, air packet will expand, will become lighter in weight. Because of that lighter in weight, there will be low pressure near the hot temperature areas. Remember, high temperature is associated with low pressure. Okay, so this is one phenomena. And if you see the second phenomena, let us assume some air has been coming down, which is called as descending air. Let us assume this is the earth surface and some air have been coming down. Okay, so wherever the air is coming down, so remember, this air is coming down and it is hitting this earth surface, right? Once this air is coming down and hitting this earth surface, there will be a kind of pressure is applied on this surface. If more and more air is coming and hitting the earth surface like this, so lot of air will start accumulating here. Okay, because more and more air from the top is coming down and hitting this surface, and lot of air will start accumulating. Once a lot of air is hitting the surface and accumulating here, the pressure will increase. Pressure will increase. So if you see, wherever descending air is there, there the temperature will be, remember, the temperature will be low and pressure will be high. Okay, remember, wherever the descending air is there, so there the pressure will be very high because lot of air will start accumulating, and in the process the air will also become cooler and cooler, so that the temperature will also become cooler. Okay, so if you see in these two cases, okay, so wherever air is rising and because of high temperature and low pressure, this one will lead to the formation of clouds and associated rainfall. But wherever the air is descending, so the air will start hitting this one, so pressure will increase, so there will be high pressure and also there will be low temperature associated with this phenomena. And remember, wherever air is descending, there will not be any chance of forming clouds. Okay, wherever the air is descending, there won't be any chance of forming clouds. Wherever air is rising, the rising air, if it has moisture content, then it will condense and will lead to the formation of clouds and gives rainfall. Okay, so rising air will form clouds, descending air will never form clouds, so there will be very dry conditions wherever there is air descending in any region of the world. So please remember these two phenomena. Okay, wherever air is rising, it will lead to the formation of clouds and gives rainfall. Wherever air is descending, okay, so wherever air is descending, the temperature will become very low and also pressure will be very high, so that there won't be any chance of cloud formation. Once there is no chance of cloud formation, then there won't be any chance of giving rainfall in this region. Is it clear? Ascending air, clouds and rainfall. Descending air, there won't be any chance of rainfall. So majority, if you see, wherever air is descending in general in the world, if you see the regions wherever air is descending, generally we will see deserts. Okay, generally deserts are seen in those areas wherever the air is descending. So the descending air, as we just came to know, it will not form any clouds, so there won't be any chance of forming clouds near the desert area, so that there won't be any chance of rainfall in the desert region. So please remember this topic also, but we will discuss this one separately, how deserts in the world are formed also. There is a separate topic in there we will discuss, but as a reference I have mentioned here that wherever descending air is there, there won't be any chance of forming any rainfall. So deserts are generally formed in the regions where our descending airs are there. Is it clear? So we have dealt with two topics, upwelling, downwelling, and also ascending air and descending air also. Is it clear? So based on these two topics, major topics, we will see the main class regarding this El-NINO and La Nina. Is it clear? So before knowing about El-NINO and La Nina, we will see what are the general thing that is occurring in the ocean and surface atmosphere near the Pacific Ocean. Okay, so generally this El-NINO and La Nina is generally seen in South Pacific Ocean. Remember, this phenomena is generally associated with South or Southern Pacific Ocean. Okay, so this phenomena is generally seen in Southern Pacific Ocean. If you see this is India. Generally some equator will be passing somewhere here. Okay, somewhere here equator will be passing. So below this one we have the southern hemisphere. So this is the Pacific Ocean, and this phenomena is generally associated with Southern Pacific Ocean. Okay, so we'll see what are the phenomena that is there in normal years, and then how this normal year phenomena will be changed during this El-NINO and La Nina. Is it clear? So let us see now. Okay, so let me draw, this is Australia, this is South America, this is Australia, this is South America. Is it clear? So now we will see in normal years how the things will be there in the normal years, and then we will see how the things will be changed during this El-NINO and La Nina. Is it clear? So in normal years, if you see from South America, from the land surface, there will be winds that are blowing away from the land surface towards the water. Okay, so from land towards the coast, winds will start blowing. Okay, in normal years, as just now we have seen, there are water away from the coast. Some empty space will be created here. Because of that one, some water will start coming towards the surface, which is called as upwelling. Okay, so in normal period, upwelling will take place in South America coast, because these winds will start dragging some water from the surface near the coast of South America, and this water, whatever that have been dragged from here, this water will start traveling throughout this South Pacific Ocean, and it will start accumulating on the Australian coast. Whatever the water that have been dragged from South America coast will be pulled towards this Australian coast, and this water will start accumulating on the Australian coast. In the process, this whatever the water that is traveling on the surface will start becoming warmer. Okay, so this, because it has to travel hundreds of kilometers, right, from South America towards Australia. So in the process of traveling, this whatever the water that is there, this water will start becoming warm. Okay, so warm water will start accumulating on the Australian coast. Okay, remember, warm water will start accumulating on the Australian coast, and just we have seen wherever warm water is there, okay, the air above that warm water, okay, the air above the warm water, when it is attached to the warm water, it will also become warmer. Okay, this air, when it becomes warmer, it will try to expand. Once it expands, then it will start to rising. Okay, so the air that is present on the Australian coast, okay, will also become warm. So it will, so here if you see, temperature is high. So as air starts expanding, its pressure will become low. So high temperature will be there, low pressure will be there. So and this air will start rising from here. Remember, this air will start rising from here because there is accumulation of hot water on the Australian coast. Once this warm water will start heating this surface air, and this air, when it rises, in the process of rising, it will become cool, and it will also condense, and it will also give some rainfall on the Australian coast. So remember, where we are getting rainfall in normal period, on rainfall on Australia. Okay, remember this one, during normal periods, here warm water will start accumulating, and this warm water, when it rises, it will give rainfall on the Australian coast. But whatever the air that have been raised here, there is a layer in the atmosphere which is called as tropopause. Remember this tropopause, which we will discuss this one in atmosphere layers. But remember, for time being, there is a layer of the Earth's atmosphere which is called as tropopause. Okay, after that a new layer will start called as stratosphere. So after reaching whatever the air that is traveling here, once it reaches close to the tropopause, okay, it will hit the tropopause, and this air will start diverting into different directions. Okay, after hitting the tropopause, this air will start diverting into different directions. Remember, this also, the warm air which is after hitting tropopause will take a diversion like this. Okay, so in the process of traveling, okay, remember, in the process of traveling, this warm air will become cool. Okay, this, in the process of traveling, this warm air will also become cool, and once it becomes cooler means, it will try to contract. Once it contracts means its density will start increasing. Once its density will increase means its weight will increase. Once its weight is increasing means the air will start sinking down. So remember, this air that have been traveling in this direction, in the process of movement, it will become cool, and after becoming cool, its weight will increase to such an extent that it cannot travel further in horizontal direction. Instead of that one, this air will start descending near to the South American coast because it has become cooler. Okay, so remember, the air weight has been increased, and because of increasing in the weight of the air, it will try to come down. Okay, so the air will start descending here, and as we just now have seen that wherever air is descending, the temperature will be low and the pressure will be high. So high pressure will be there here and temperature will be low. So if you see in the atmosphere, some air is rising here and it has taken a diversion here, and that air has been descending here. But on the surface of the water, if you see, the water has been started moving on the surface in this direction. So if you see, if you combine the air direction and water direction, there will be a cycle which is formed here. If you see, okay, so if you can see a kind of cycle, these three are nothing but with respect to atmospheric phenomena, and this is on the surface of the water. So if you combine these two, then there will be a cycle. This cycle is called as Walker cycle. Okay, Walker cycle. This cycle is called as Walker cycle, and this cycle will be generally seen in normal years in this South Pacific Ocean. So as we have discussed, whenever air is descending, is there any chance of rainfall? No, because they won't form any clouds. So because of that one, there will be very dry conditions that are seen on this South American coast. Because of that one, we have one of the largest desert in the world here present, which is Atacama Desert, which is present in this South America, because there will be very less amount of rainfall that is occurring because the air is descending in this region. So this is general phenomena that is occurring in normal years. Is it clear? So if you see from this picture, so the winds that are blowing from the land towards the coast will try to drag the water towards Australia coast, and whatever the water that is coming towards the Australia coast, this water in the process of movement, they will become warmer. Once these, whatever the water that is becoming warmer, means that warm water will start accumulating on this Australia coast. Whenever this warm water accumulated in this Australia coast, here the air that is attached to this warm layer will become warm and it will expand and it will try to rise, and after hitting the tropopause, this will take a diversion in this direction. In the process of movement, it will become cool, and once it become cool, it will contract and its weight will increase. Once its weight increases, then it will try to descend here. Once it descends here, then it will having high pressure and low temperature, and here it is having high temperature and low pressure. Okay, so if you combine this atmospheric and water surface phenomena, this is nothing but called as Walker cycle. Okay, this is occurring in normal years, but after 7 or 8 years, there is a peculiar phenomena where the reversal of this Walker cycle will occur. Okay, there is a reversal of this Walker cycle will take place generally after 7 or 8 years on an average, if you see. Okay, so let us see what will happen during this reversal of Walker cycle, which is nothing but called as El-NINO year. Okay, so whatever the normal conditions are there, those normal conditions will be reversed during a particular year. That year is called as El-NINO year. Okay, so let us see how these things are reversed, and we'll see what are the major things that are taking place during this reversal. Okay, so previously we have discussed some air that is blowing away from land towards the ocean. This air will try to drag the water towards the Australia, right? But now after 7 or 8 years, this air will start becoming weak. Okay, so this air will start becoming weak. Once this air is becoming weak, so can it pull this water away from the coast? No, it's very difficult for this weak air to drag water towards the Australia coast from the South America coast. Okay, so once this air becomes weak, it cannot drag the water, as there is no movement of water from South America towards Australia. Okay, so whatever the water that have been went towards this one will try to start coming backwards towards this South America coast. Remember, because of weakening of these winds that are blowing from South America towards the ocean, these winds will become weak, and because of that one, whatever the water earlier has started moving in this direction, now will start becoming reversal in this direction. Okay, remember, this water will start moving in this direction. But remember, there is one cold current which is blowing on the coast of South America. Remember, there is a cold current. Cold current is nothing but a big stream of water which is very cold. Okay, we will see this thing in oceanography topic, different cold currents and warm currents that are present in the world. But for time being, remember, there is a cold current that is blowing on the South America's coast. This is the cold current which is blowing like this in the South America coast. But as during El-NINO year, as warm water that is accumulated near this Australia coast will start coming backwards, this warm water will start accumulating near now this South America. Remember, earlier warm water started accumulating near Australia, but because of weakening of this wind, this warm water will start moving backwards. This warm water will start moving backwards and will try to accumulate near the South America coast. See here, lot of warm water will start accumulating at the South America coast. Because of accumulation of this one, whatever the cold current that is there, this warm water will start mixing with that cold current, and it will also weakens the cold current, and it will disappear the cold current from this South America coast. Okay, so that entire South America coast will be accumulated with a lot of hot water. Okay, so wherever, just now we have seen, wherever hot water is there, the surface or the air that is attached to the hot water surface, that will start expanding. Once it is expanding means it will become lighter in weight. Once it is lighter in weight, then there will be low pressure. Okay, so once it is becoming lighter in weight, it will try to rise from here. Remember, as the air become lighter in weight, it will try to rise from here. Once it is rising here, after hitting tropopause, the same phenomena, after hitting the tropopause, this air will start diverting in different directions. Okay, so this warm air, after rising here, some warm air will start forming clouds and it will give rainfall in this region. Rainfall in South America. Okay, so rainfall, little bit rainfall will be given in the South American region, and after hitting the tropopause, this warm air will start diverting in this direction, and in the process of movement, okay, this warm air will become cooler and cooler with time. Once it becomes cooler, it will try to contract and its density will increase. Once its density is increasing means its weight will further increase. Once its weight is increasing means it cannot travel further in horizontal direction. Instead of that one, it will try to come down. Okay, so it will try to descend near this Australia. Okay, so this air will start rising here and it will move in this direction and it will try to descend near the Australia. Is it clear? And just we have seen wherever air is rising, it will form clouds and it will give rainfall. So now this entire South America coast will get rainfall, and wherever the air is descending or coming down, there won't be any chance of forming any clouds. So here there won't be any chance of forming clouds on the Australian coast. Because of that one, entire Australia and surrounding regions will get very less rainfall. Less rainfall, or we can see drought conditions. Or we can see drought conditions on the Australian coast. In normal years, on Australia we are getting rainfall, but on the South America coast it is a dry or desert region, or drought conditions will be seen. But now in El-NINO year, South America is getting some rainfall, but Australia is getting drought. But if you see this hotness or whatever, this less, see wherever this air is descending, that will not give any rainfall, right? So this area, entire area including India and Southeast Asia region will also get relatively lesser rainfall during this El-NINO. Okay, so if you want to connect El-NINO with India means our monsoon will become weak, our monsoon winds will become weak. So due to that, monsoon rains will start reducing during this El-NINO year. So if you have El-NINO year, then India will receive lesser rainfall during monsoon season, because air is descending on the Australian coast, and wherever air is descending, it will not form any clouds. So wherever no clouds, there won't be any chance of rainfall. Is it clear? So remember, during El-NINO year, India will also get little less rainfall, and Australia is also getting less rainfall. Is it clear? So this is El-NINO. So if you see on the surface, the water have been moving like this, and atmosphere if you see like this. But previously if you see, this is the Walker cycle, right? This is the Walker cycle, but now the Walker cycle have been reversed. Can you see? This is the Walker cycle which have been reversed in this El-NINO case. Okay, this is normal year, this is El-NINO year, where the Walker cycle have been replaced, or we can say the warm water on the Australian coast will move towards the South America coast, and the cold water on the South America coast is replaced by warm water, is nothing but called as El-NINO year. Is it clear? Done. So there is one more associated phenomena with this El-NINO, is nothing but called as La Nina. Okay, La Nina is nothing but intensification of Walker cycle. Okay, it is nothing but the same Walker cycle, means whatever the phenomena that is seen during normal year, that is only seen during La Nina, but there is intensification of normal year, or intensification of Walker cycle will be seen here. Means whatever the winds that are previously seen here, that are blowing away from the land towards the ocean, these winds, whatever the winds that are blowing here, right, these winds will start moving at very high speed. Okay, lot of winds will start moving from land towards the coast, and these winds will be blowing with very high speed. As these winds are very high speeds and lot of winds are blowing, they will try to drag lot of water towards this Australian coast. Okay, they will try to drag lot of water compared to normal year. They will try to drag lot of more water towards the Australian coast, and in the process, whatever the water that is more towards the Australian coast, this entire water will become very warm. Okay, so previously some amount of water will become warmer, and that warm water will start expanding, means whatever the air attached to that one will start expanding and it will rise. But in this case, as more water have been dragged, more warm water will be accumulated. So because of more water accumulated at the coast, the air attached to that coast region will also be in huge amount. So more air will start expanding here, more air will start expanding, and in the process more air will start rising. As more air is start rising, if that more air is having more moisture, then it will form huge clouds here. It will form huge clouds here, and once we have seen, wherever huge clouds are there, it will give huge rainfall. So in previous time, it was normal clouds are formed and it will give rainfall. But here, as more water have been dragged, more hot water is accumulated here. As more hot water is accumulated, more air attached to that will also become warm, and this whatever the air that has become warm will start expanding, and in that process more and more air becomes lighter and it will uplift towards the surface, and in the process of uplifting it will become cool and it will condense and it will give rainfall after forming as a clouds. Okay, so more rainfall will be seen on this Australia coast, and as after hitting this tropopause, this air will start moving in this direction, and in the process of moving horizontal, it will become cool and its density will increase and its weight will further increase, so that air will start descending down. As here more and more air is going, so more and more air is also descending here, and we have seen wherever air is descending, there won't be any rainfall. So more and more air is descending means very less chances of rainfall. So if you see in this year, okay, after El-NINO, generally we will see this La Nina. In this La Nina, if you see, there will be a kind of huge amount of rainfall will be seen once again in Australian coast. Nothing but this time it will be having floods. Okay, we can see in previous year, in normal cases rainfall is seen, but in La Nina, because of huge amount of air that is uplifting, it is forming huge amount of clouds which will form into huge amount of floods in this Australia. And previously on South America, here we have seen dry conditions, but now as more air is descending, there won't be any chance of rainfall, so it will become more and more drier region, so that there might be chances of becoming drought conditions in this entire South America. So if you see, as Australia is getting more rainfall because of this huge formation of clouds, this Indian region will also receive huge amount of rainfall during La Nina. Remember that one, during La Nina, Indian coast or India will also receive huge amount of rainfall, but during El-NINO, India will also receive less rainfall along with Australia. Okay, so if you connect El-NINO and La Nina, so I will write here El-NINO with respect to India, monsoon will decrease, means less rainfall will be seen in the monsoon, and if you see La Nina, monsoon rainfall will increase. Okay, so during El-NINO and La Nina, we have to interconnect with our India, how it is impacting Indian monsoon. But if you see, these El-NINO and La Nina are not only the two phenomena that are impacting our Indian monsoon. There are other phenomena also there which are impacting our Indian monsoons, like two more topics are there which are called Madden-Julian oscillation and also Indian Ocean dipole. These two phenomena are also impacting our Indian monsoon. So overall, if we have to see all these four phenomena, because all these four will not occur at a time. Okay, so if sometimes two might occur at a time, sometimes only one will be there. So based on that one, we have to see whether our Indian monsoon will be increased or decreased because of these associated phenomena. Is it clear? So we'll see some diagrams with respect to this El-NINO and La Nina, then we will go to this Indian Ocean dipole and Madden-Julian oscillation. So if you see from this picture, so this is normal year, okay. So normal year, lot of hot water, so these winds will start dragging here, so whatever the winds that are moving will start accumulating here on the Australian coast, and because of that one, the air will become warm and it will expand and it will rise and it will lead to the formation of clouds, so that these clouds will give rainfall on this Australia and surrounding regions. After hitting tropopause, these airs will move in different directions. In the process, this air will become cool, and once it becomes cool, its weight will increase, so it will try to descend here. Is it clear? This air will try to descend here and the water will start moving on the surface. So a cycle has been formed, which is nothing but called as Walker cycle or Walker circulation in normal years. Is it clear? So same, if you see in El-NINO year, the reversal of Walker cycle will take place, where the warm water will start moving towards this South America and warm water will start accumulating here. Okay, so because of this warm water accumulating near this South America, the air at the South America will start ascending. Okay, so the air which is ascending here will lead to the formation of clouds and will give rainfall on this South America, and after hitting tropopause, this air will move in different directions, and in the process of movement it will become cool and it will start to descend here, and once it descends here, it will not give any kind of rainfall here, so a kind of dry region will be seen in this Australia and India region during this El-NINO year, and this cycle of Walker cycle will be reversed completely in this period. Okay, this generally phenomena is seen around 7 to 8 years on an average, and after every El-NINO year there might be chances of occurring in a La Nina year also. So we will see where La Nina is nothing but once again the forming of Walker cycle conditions, but this time the Walker cycle will be very intensified, means more intensification of normal conditions will occur. So because of that one, if you see, lot of warm water will start accumulating here on this Australia coast. Because of lot of warm water, more air will start rising here. So once more air is rising here, huge clouds will form. This will give huge amount of rainfall. Even to India also will receive good amount of monsoon, and more winds will start moving in different directions, and in the process they will become cool and their weight will increase. They will try to recede here. Okay, so in that process, once again the normal Walker cycle will be formed, but it is intensified Walker cycle will be seen during La Nina year. So I think we have discussed how these two phenomena will be associated with Indian monsoon. Okay, so we will see two more other topics linked to this one. So if you see the pictures, okay, so I'll discuss one more topic is there, but before that one, first we will see Madden-Julian oscillation we will see, then Indian Ocean dipole will be there, and one more topic is also there. So we will discuss these things and then we will close the class. Okay, so whatever the Walker cycle we have seen here, right? So this is the Walker cycle just we have seen on the Australian coast. The air is rising. After reaching here on the South American coast, the air is descending. South America, the air is descending, and on the Australian coast the air is rising. This is the Walker cycle, right? So this cycle is constant. Okay, this cycle is constant in normal conditions, but in Madden-Julian oscillation, in Madden-Julian oscillation, this cycle is not constant. This cycle will start moving from west to east in this direction. Okay, this cycle will start moving from west to east in this direction. Means, see, this one is there here, but after some time, okay, this cycle will be generally seen for 30 to generally 60 days. Okay, means let us assume this is right now at this moment it is there near Australia and South America. After few days, if you see, this cycle has been shifted to somewhere near Africa. After few days, if you see, this cycle will be shifted towards India. After few days, if you see, this cycle will be shifted towards once again Southeast Asia and then Australia. So within 30 to 60 days, this cycle will means encirculate entire world. Okay, means let us assume it has started at this A location today. After in between 30 to 60 days, it will encircle this entire world and it will come back once again to this same location after 30 to 60 days. Okay, So the same Walker cycle thing, where on one wing the air has been rising, on another wing the air has been descending. Okay, so on one wing the air has been rising, on another wing the air has been descending, right? So this thing will start continuously moving from from west to east, like this, in this direction. For suppose, let us assume, okay, so this is nothing but called as Madden-Julian oscillation. And for example, if this rising wing, okay, this rising wing comes over Indian landmass, let us assume this is India, let us assume this rising wing is there on Indian landmass, and as we discussed, wherever air is rising, it will lead to the formation of clouds, right? So once this air rising wing is over India, means this wind will start rising here. Once the winds will start rising here, then it will lead to the formation of clouds. So once clouds are formed, then it will give rainfall over Indian region. Okay, so once this rising wing is there over India, then it will give rainfall over Indian landmass. But for suppose, let us assume if Indian landmass is there on this descending, means this descending wing is there on Indian landmass. Okay, so this descending wing is there on Indian landmass means wherever descending air is there, then it will not have any kind of formation of clouds, so that there won't be any rainfall here. So if this descending air is there on Indian landmass, then there won't be any chance of rainfall over Indian landmass. Means if Madden-Julian oscillation rising is there on any landmass, then it will give rainfall on that landmass. If it is having descending wing on that landmass, then it will give no rainfall on that landmass for the time period. So if the same phenomena is occurring during Indian monsoon, for example, Indian monsoon is there during July or June, okay, if rising wind is there on Indian landmass during June, okay, Indian monsoon will give certain rainfall, but this rising air will also give certain rainfall. So total amount of rainfall during monsoon will increase. But if this descending air is there during monsoon, monsoon will try to give certain rainfall, but this descending air will not try to give any rainfall. So the amount of rainfall that is coming into the Indian landmass will start reducing if this descending wing of Madden-Julian oscillation is there on Indian landmass, because this circulation will encircle entire world within 30 to 60 days, and it is not a constant thing. It is keep on moving like this. So if you see here, there is a rising air and it will lead to the formation of clouds, it will give rainfall. After hitting tropopause, it will move, it will become cool, same phenomena, it will come down. Okay, so total a circle will form, but this circle, whatever the cycle that is formed, it is not constant, but this cycle will start moving towards east from the west direction. So it is moving from west to east in this direction. So it is continuously keep on moving from landmass to landmass, from continent to continent, from ocean to ocean within 30 to 60 days throughout the globe. Okay, understood? This is nothing but called as Madden-Julian oscillation, and we have also discussed how it is associated with Indian monsoon. For example, if rising wing is there on Indian landmass, then India will receive huge amount of rainfall, and if descending wing of Madden-Julian oscillation is there on Indian landmass, then Indian landmass will receive less amount of rainfall during this season. Is it clear? Okay, so one more phenomena we'll see, Indian Ocean Dipole. It is also associated with this phenomena. Okay, so Indian Ocean Dipole. So dipole, what is meaning of dipole? Dipole is nothing but having two different polarities or two different poles, means nothing but two things which are opposite to each other. Okay, two things which are opposite to each other. For example, in this Indian Ocean Dipole, we will see especially this Indian Ocean phenomena. See, what are the phenomena that is occurring in the Indian Ocean that is taking place here. Okay, so in this one, if you see, okay, so because of some phenomena, some unknown reasons, there are this entire Indian Ocean. Okay, so this is Western Indian Ocean, this is Eastern Indian Ocean, right? This is Western Indian Ocean, this is Eastern Indian Ocean. So due to certain unknown phenomena, sometimes this Western Indian Ocean is becoming warmer, and as this is dipole phenomena, once this Western Indian Ocean is becoming warmer, this Eastern Indian Ocean is becoming cooler. Okay, the same way when Eastern Indian Ocean is becoming warmer, then Western Indian Ocean is becoming cooler. Okay, so because of these polarity or opposite things, there is certain phenomena which is nothing but called as Indian Ocean dipole, and how this Indian Ocean dipole is having impact on our Indian rainfall. Okay, we'll see. So let us take one case. Okay, so let us take first one, positive Indian Ocean dipole. Okay, let us take first one, positive Indian Ocean dipole. IOD means shortcut for Indian Ocean dipole. Okay, so in this case, the Western Indian Ocean, whatever the Western Indian Ocean which we have just now seen, the Western Indian Ocean will become warmer. Okay, the Western Indian Ocean becomes warmer. This is becoming warmer, and as just we have seen, once one side it is becoming warmer means the other side is becoming cooler for unknown reasons. So this Eastern Indian Ocean is becoming cooler, and just we have seen wherever it is becoming warmer, the entire air on the surface will become warmer, so it will try to expand. In the process of expansion, it will become lighter in weight, so low pressure will be there, high temperature will be there, the air will start rising. Okay, so the air will start rising here, and just now we have seen wherever air is rising, it will lead to the formation of clouds, and these clouds will condense and will lead to the formation of rainfall. So if you see during this, if you see, positive Indian Ocean dipole is nothing but Western Indian Ocean minus the temperature of Western Indian Ocean minus the temperature of Eastern Indian Ocean. Okay, the temperature difference of Western Indian Ocean and Eastern Indian Ocean is nothing but called as Indian Ocean dipole. If you see, the temperature difference of Western Indian Ocean minus temperature difference of Eastern Indian Ocean, if this is becoming positive, means the temperature of Western Indian Ocean is higher and the temperature of Eastern Indian Ocean is lesser. So once it is positive, then it is called as positive Indian Ocean dipole. If the temperature of Western Indian Ocean is cooler, means it is lesser temperature compared to this Eastern Indian Ocean, means let us assume this temperature is around 5 degrees and here the temperature is around 15 degrees because it is warmer, right? So in this case it is becoming minus 10 degrees, right? So once it is becoming minus, then it is called as negative Indian Ocean dipole. So positive Indian Ocean dipole means the temperature of Western Indian Ocean will be greater than the temperature of Eastern Indian Ocean, and in negative Indian Ocean dipole means the temperature of Western Indian Ocean will be lesser than the temperature of Eastern Indian Ocean. Is it clear? So once the temperature of Western Indian Ocean is warmer, the air attached to it also will become warmer and it will expand and it will rise and it will give huge amount of rainfall in this region. So because of that one, this entire Indian region will also receive huge amount of rainfall. So during positive Indian Ocean dipole means temperature of Western Indian Ocean is greater than temperature of Eastern Indian Ocean. During this positive Indian Ocean dipole, India will receive receives huge rainfall. Remember, India will receive huge rainfall when there is positive Indian Ocean dipole, where the Western Indian Ocean will be warmer compared to the Eastern Indian Ocean. And if you know, as we have seen, the air which is rising here, okay, after hitting tropopause, it will take different directions here. Once after reaching here, it will become cooler, and in the process, once it becomes cooler, its density or its weight will increase, so it will descend here. So a kind of cycle can be seen here, but huge amount of rainfall will occur here. But as air is descending here, this entire region of Australia and Southeast Asia will become very dry. Okay, this Australia and Southeast Asia will become very dry during positive Indian Ocean dipole, but India landmass will receive huge amount of rainfall during this Indian Ocean dipole phenomena. Is it clear? So if you see the other phenomena, that is negative Indian Ocean dipole, okay, if you see here, the temperature difference negative negative Indian Ocean dipole, means the temperature difference of Western Indian Ocean is less than the temperature of Eastern Indian Ocean, means, or I can write this equation as temperature of Eastern Indian Ocean is greater than temperature of Western Indian Ocean. Okay, so if you see, temperature of Eastern Indian Ocean is higher and temperature of Western Indian Ocean is lesser, and as temperature is higher here, the air that is in contact with the surface water will become warmer, it will expand, it will try to rise, okay, and in the process of rising it will become cool, condense, and finally it will give rainfall on this entire Australia and Southeast Asia. But if you see, this air after traveling here will become cool, and cool air will try to descend here, and we know as air is descending it will not form any rainfall, so entire Indian region will not receive any kind of rainfall during this negative Indian Ocean dipole, because the airs are started descending here. Is it clear? So if you see, Australia and Southeast Asia is receiving rainfall during negative Indian Ocean dipole, but Indian landmass will receive no rainfall during negative Indian Ocean dipole. So at the same time, if you connect with our monsoon, if negative Indian Ocean dipole is there, monsoon is giving some rainfall, but this one descending air, it will not give any rainfall, so our Indian monsoon will try to reduce during this negative Indian dipole period. Similarly, if positive Indian Ocean dipole is there, means already monsoon is giving certain rainfall, but this positive Indian Ocean dipole will be increasing the amount of rainfall because more clouds will be formed in this region, so because of that one, more rainfall will start occurring on the Indian landmass. Is it clear? So this is how we have to connect Indian Ocean dipole with our monsoons, especially positive Indian Ocean dipole and negative Indian Ocean dipole, and also how the Madden-Julian oscillation is also associated with our Indian monsoon, and also we have to know how this El-NINO and La Nina are also associated with our Indian Ocean monsoon. Okay, is it clear? So after this, there is one more small topic is there associated with these two, which is called as El-NINO Modoki and La Nina Modoki. Okay, so El-NINO Modoki and La Nina Modoki. So just these are just very small topics. So if you see here, El-NINO, till now we have seen this El-NINO, right? So near this South America coast, air is rising here, it is forming clouds and it is giving rainfall here. This air is moving here. Okay, a kind of cycle, reversal of Walker cycle will occur here, right? This is El-NINO. But if you see El-NINO Modoki, due to some unknown phenomena, okay, due to certain unknown phenomena, the central South Pacific Ocean, central South Pacific means, see, this is entirely Pacific, but the central South Pacific Ocean is becoming warmer. Okay, the central South Pacific Ocean is becoming warmer. So once any area is becoming warmer, their air will start ascending. So from the center of Pacific Ocean, see, previously it was on the coast, either on the Australia coast or on the South America coast, but now in this case it is in the center of Pacific Ocean, means in between Australia and South America, whatever the Pacific Ocean is there, in the center of the Pacific Ocean, the air or water is becoming warmer. Once the water is becoming warmer, the air associated with it also becomes warmer, it will expand and it will try to rise. So from the center, the air is started rising. Okay, if you see, thus from the center the air is started rising, but once this risen air after hitting the tropopause, it will take diversion in different directions. Okay, it will take diversions in different directions, but in the process of traveling horizontally, it will become cooler. Once it becomes cooler, its weight will increase and it will try to descend. Okay, so this air after traveling certain distance, it becomes higher in weight, it will try to descend here. This air after traveling certain distance, it will try to descend here. Okay, so wherever the descending air is there any chance of rainfall? No. Okay, so because of that one, see, central Pacific Ocean air is rising, so here clouds will form and it will give huge amount of rainfall in the Pacific Ocean itself. There won't be any rainfall on the land, but in the mid of the ocean there will be huge amount of rainfall in the central South Pacific Ocean. But the air is descending in the Australian coast and some air is also descending on the South American coast. Because of this descending air, there won't be any kind of rainfall in both Australia and in South America. Okay, so if you see, this cycle will continue like this cycle will continue like this. So if you can see, two cycles are formed here. One cycle is this one and the second cycle is this one. Okay, so in this case two cycles have been formed, and because of this one, both Australia during El-Nino Modoki, okay, during this El-Nino Modoki year, both Australia and also South America will be drier regions, and Central Pacific Ocean will receive huge amount of rainfall. Remember this one. Okay, in normal years Australia is getting rainfall, in El-Nino years South America is getting rainfall, but during El-Nino Modoki, Central South Pacific Ocean is getting rainfall. But the land masses of Australia and the land mass of South America is receiving no rainfall during this El-Nino Modoki year. Is it clear? So the same we will have La Nina Modoki also. So in La Nina Modoki, the same opposite will happen, where the Central Pacific Ocean will become cooler. Okay, the South Central Pacific Ocean will become very cool, and the temperature on the Australian coast and the temperature on the South American coast will become warmer. So if you see here, the temperature on the Australian coast and the temperature on the South American coast will become warmer. Once the temperature is becoming warmer, the air will start rising here. So once air is rising, then it will give rainfall in this region. The rising air after hitting the tropopause will take different directions, and it will also take different directions, and these two wings of air, after traveling certain distance, these two wings of airs will start coming closer and they will merge here, and because these two winds are merging here, lot of air will start accumulating in this region. Because of this lot of air accumulating in this region, the air will start descending in this region from here. Okay, so lot of air will start accumulating in this region because two wings of air are converging here. Because of this convergence, lot of air will accumulate in this region. So once this accumulated air is there, that entire air will start descending from here. Once this air is descending from here, okay, so it will complete this cycle and this one will complete this cycle. So here also if you see, there are two cycles are formed here, and one more cycle is this one. This is one cycle and this is another cycle which is formed here. Is it clear? But if you see here, the Central Pacific Ocean is having descending air. So as we know, wherever descending air is there, there won't be any chance of cloud formation. So there won't be any rainfall in the South Central Pacific Ocean during La Nina Modoki. But as air is rising on both the coast, means on the Australian coast and also on the South American coast, as air is rising on both the coast, whatever the air that has been rising here, it will become more warmer, and in the process, if it has more moisture, means it will lead to the formation of clouds. These clouds will give rainfall on these both coasts. So if you see, in El-Nino Modoki, Central Pacific Ocean is getting rainfall and both Australia and South America are drier regions. But in La Nina Modoki, Central Pacific Ocean is receiving no rainfall, but the land masses or the coasts of Australia and also the coasts of South America are receiving huge amount of rainfall during this La Nina Modoki. Is it clear? So if you see these two phenomena together, okay, so in El-Nino year, South America is receiving rainfall, Australia is becoming drier. In La Nina year, Australia is receiving huge amount of rainfall, but South America is becoming drier. But during El-Nino Modoki, Central South Pacific Ocean is receiving rainfall on the ocean, but the coasts of Australia and South America are becoming drier during El-Nino Modoki. And during La Nina Modoki, both Australia and South America are receiving huge amount of rainfall, but the air will descend in the South Central Pacific Ocean, where there won't be any kind of rainfall during this period. Is it clear? I think we have completed the major topics of El-Nino, La Nina, El-Nino Modoki, La Nina Modoki, Indian Ocean Dipole and Madden-Julian Oscillation. So all these combinations will be seen on Indian monsoon. Then Indian monsoon will be increased or decreased when it is associated with all these topics. Is it clear? Thank you friends.